Let's get back to work. Module 3, Session 3.2. In this session, we will be discussing fault finding, one of the most important parts of the Level 4 curriculum. When your ECDE students reach the workplace, one of the jobs they will most commonly be required to perform is to repair electronic equipment. It is therefore imperative that they develop good fault-finding skills. Good fault-finding skills are vital to the electronics technician, but they are also skills that come with experience and take years of practice to master. However, there are step-by-step processes that your students can follow on how to go about finding problems with various types of electronic equipment using generic and specific procedures. Please remember that there are no shortcuts and safety must always be considered, especially when working with AC mains equipment. So where should you start? The answer to this question is different for every situation, and even with practice, you may often come across problems that cannot be explained immediately. Troubleshooting requires the technician to ask questions such as, what could have caused this to happen? Were there any signs prior to the fault occurring? Why is this voltage so low or high? If this resistance were open or short-circuited, what effect would it have on the operation of the circuit that I'm working on? Which area of the equipment could the fault be in? And so on. The ability to ask the right questions is what makes a good repair technician. Each question calls for measurements to be made and tests to be performed. The defective component is identified when measurements give results that are very different than they would be in a properly operating unit, or when a test fails. Obviously, the more you know about the equipment you are attempting to repair, the quicker the fault will be identified and corrected. It is very important that in order to service or repair a particular piece of electronic equipment, you should have at least a basic understanding of how it works. Even though they use the same components, transistors, resistors, capacitors, diodes, etc., a television set is put together differently to a DVD player, for example. However, as long as you have a generic block diagram of the type of equipment you are repairing, you will soon be able to identify which block is causing the problem, test the components in that block, take voltage measurements, etc., and rectify the problem in no time. Let's look at an example of a radio receiver circuit. All radio and other transmitted signals, emergency services, traffic control, etc., are available at the antenna. You have to tune the receiver in order to receive the one that you desire. The required radio station, SAFM, Metro FM, etc., is now selected from the rest using the tuner, which is normally a variable capacitor or varactor diode. The radio frequency is amplified just a little because it is very weak during transmission. The signal then goes through the various stages until it reaches the detector stage. Here, the carrier wave and the original content transmitted by the radio station are separated, normally by using a diode. The carrier wave is discarded and the original content, music, news, talk shows, etc., is sent to the audio amplifier to increase the signal level. The amplified signal is then sent to the speaker where it is now audible to everyone. The volume control is used to adjust the sound level as required. Fault finding. Now, let us assume that the radio is working. You can tune in a station, Metro FM, but can only hear a very soft or distorted audio at the speaker. In other words, there is no real volume at the output, even though the volume control is set at the maximum level. Which block does your common sense tell you could be the problem area, even if you know very little about radio receivers? The IF amplifier, the tuner, the detector stage, speaker, audio amplifier stage, antenna, mixer? It has to be the audio amplifier stage, because the sound entering the antenna is generally weak, gets amplified just a little by the RF amplifier, and then sent to the output. The signal needs amplification, which is not happening. That's why the volume at the speaker is so soft. The first thing to check is the supply voltage to this particular section of the radio using a multimeter. If it is missing, the problem must lie in the power supply section, which is responsible for supplying the 12-volt or an open circuit resistor that is normally connected in series from the power supply to the amplifier. Notice how the focus has now shifted to another area of the receiver, the power supply. If the voltage is present, but lower than 12 volts, then one or more of the components, normally transistors or an integrated circuit in the amplifier stage, is faulty. A faulty component always tends to draw more current, thereby reducing the voltage due to Ohm's law. This is one of the best clues that one could hope for. The faulty component should be removed and tested for correct functioning and replaced when necessary. It will serve your students well to remember the following. Usually, you can solve the problem just by using a logical and methodical approach to fault finding. Please do not start removing and replacing every component you see. It is time-consuming, costly, and the chances are that you could actually put in a fault that was never there in the first place. Know where to focus your attention, which block or area, and then start your troubleshooting procedure. End of Module 3.